All right, last video podcast of the trimester. I have Kleenex if any of you want to borrow any, just let me know. I know you're shedding tears at this point. 62. You read in a book about bridge that the probability that each of the four players is dealt exactly one ace is about 0.11. What does that mean? Well, and the key to this is we're talking about not just 100, but in many, many, many bridge deals. And this one, million is a lot, but then they say exactly, that's no go. So C and D are the closest, and the big difference is we are talking about the percent of deals being close to 11% when we talk probability, not the average number of anything. So C is the correct interpretation there. If I toss a fair coin 5 times and the outcomes are tails, 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 then the probability of the tail appears on the next toss is always 0.5 for the next toss. This is the old gambler's fallacy to see if they can trick you. The next two exercises follow this setting. A basketball player makes 47% of her shots from the field during the season. To simulate whether a shot hits or misses, you would assign random digits as follows. 1 digit simulates one shot, 4 and 7 are hit, the other digits are miss. Well, that would be 20%, and that won't work because 4 and 7 are 2 of the 10 digits. 1 digit simulates one shot, odd digits are a hit, and even digits are a miss. This is closer, but now it's 50-50, and that's not the percent. She used 47. 2 digits simulate one shot. 0, 0 to 4, 7 are a hit, and 4, 8 to 9, 9 are a miss. That's even closer, but that's 48%. So it is D that we need. If you go 0, 0 to 4, 6, that would give you exactly 47 digits, and that leaves you with 53 that aren't, so huzzah. So then now using this choice, we want to simulate 10 shots. So we're going to look every two numbers. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The rest we don't care about. And looking at these numbers, only 0, 0 to 4, 6 are a hit. So we missed because it's bigger than 46. We missed because it's bigger than 46. We missed just barely. Not really. Our random number table did not determine how close we were. But in terms of numbers, we just missed 47 to be a miss. 14 is finally we hit a shot. 90 is a miss. 20 is a hit. 46 is a hit. 74 is a miss. 75 is a miss. And 11 is a hit. So there were only four pairs of numbers that were between 0, 0, and 4, 6. So we had 4 shots that we hit. Final 10 questions. In government data, a household consists of all occupants of a dwelling unit. Choose an American household at random and count the number of people it contains. Here is the assignment of probabilities for your outcome. And the big key is the probability of finding 3 people in a household is the same as the probability of finding 4. So these two are both the same. So if we take and add up all the ones that are there, 0.25 plus 0.32 plus 0.11, 0.03 plus 0.01, it is 0.68. 1 minus 0.68 leaves us 0.32. And since they are the same, we can cut that in half to get 16%. Had they not told us that it was the same for both, then we'd be a little bit stuck. The casino game Craps is based on rolling 2 dice. Here's the assignment of probabilities to the sum of numbers on the up faces when 2 dice are rolled. The most common bet in Craps is the pass line. A pass line better wins immediately if either a 7 or an 11 comes up on the first roll. This is called a natural. What is the probability of a natural? Well, rolling a 7, a sum of 7, and rolling a sum of 11 are mutually exclusive. They cannot both happen at the same time. So if we want the OR probability, we can just add them together. 6 out of 36 plus 2 out of 36 would give us 8 out of 36. 68. An athlete is suspected of using steroids is given 2 tests that operate independently. Independently of each other. Test A has a probability of 0.9 of being positive if steroids have been used. Test B has a probability of 0.8 of being positive if steroids have been used. What is the probability that neither is positive? So what is the probability of negative if steroids have been used? Since they are independent, we can just multiply the probability that the first one is negative times the probability that the second one is negative. We only have the probabilities that they test positive, though. Whatever will we do? We'll use complements. So 0.1 times 0.2, times 0.2 gives me 0.02, in case you doubt me. And you know, it's getting late. I've done a lot of podcasts and grading today. I'll just check my mental math. Thank goodness, 0.02. The last 3 on this page, for me. For you, it's just the end of a column. Refers to the following setting. 1,000 students at a city high school were classified according to both GPA and whether or not they consistently skipped classes. The 2A table below summarizes the data. What is the probability that a student has a GPA under 2.0? Well, we're going to need some totals. There are 255 students who had a GPA under 2. And altogether, there are 1,000 students. I might as well total up those other ones while I'm here. So this is 110. Oops. We could just subtract from 1,000, but maybe I'll add up this way just to be safe. Kind of confirm my other numbers. Okay, good. 110 plus 890 does give us 1,000, so life is good. So what is the probability a student has a GPA under 2.0? Well, here are all the students that have a GPA under 2.0, so it's 255 divided by 1,000, which is 0.255, letter B. 70, what is the probability that a student has a GPA under 2.0 or has skipped many classes? So there's a couple ways you could do this. We talked about how to reason through it on the table before by carefully adding. But another way to do it is just to do the probability that under 2 or many, that's what we're finding, is the probability of under 2 plus the probability of many minus the probability of under 2 and, sorry, I'm going off the page, many. So it's just applying the formula directly. So the probability of under 2 is 0.255. That's the one we just found. Plus the probability that they've skipped many times would be 110 over 1,000, which is 0.110. But then we have to subtract the probability that they are under 2 and many because we counted those with both groups. So minus 0.08. If we crunch some numbers, .285, which is C. Oops, wrong question. The other way to do this is just say, okay, under 2 or has skipped many classes. Here are the people that are under 2. Many classes is all of this, but I've already counted 80, so I could just add in 80, 175, 25, and 5. And that would be another way to get to the same answer. Last one on the page. What is the probability that a student has a GPA under 2 given they've skipped many classes? So now what we need are just our good old probability of under 2 and many divided by whatever's after that conditional. Well, the probability of under 2 and many is 0.08. Divide, or you could just do 80 really. divided by the probability of many is, oops, I kind of erased it, that 1.110. 0.72727, so E. Here we go. Last couple questions. For events A and B are related to the same chance process, which of the following statements are true? And it's basically all about mutually exclusive and independent. And if we look at these, if they're mutually exclusive, they must be independent. No, in fact, it can never be both. If they're independent, then they must be mutually exclusive. No, they can never be both. If A and B are not mutually exclusive, then they must be independent. That's not true. You don't have to be in one or the other. If A and B are not independent, then they must be mutually exclusive. No, they do not have to be in one or the other. So we're left with E. And this is false. If A and B are independent, then they cannot be mutually exclusive. Sorry, this is the one that's true. If A and B are independent, then they cannot be mutually exclusive. That's true. Since we can't be both, if this is true, mutually exclusive will not be. Choose an American doll at random. The probability that you choose a woman is 0.52. The probability that the person you choose has never married is 0.25. The probability you choose an adult who is a woman and has never married is 0.11. The probability that the person you choose is either a woman or has never been married is about, well, the probability of W or NM is going to be 0.52 plus 0.25, the probability of one plus the probability of the other, minus that overlap. .66, letter B. Same exact situation. So I'm not going to rewrite everything, and I'll refer to this up here, but now we want the probability of woman given never married. Whoops, not NB. That's going to be the probability of W and never married divided by the probability of never married, which is woman and never married was that 0.11. Probability of never married was 0.25. And then if we crunch that out, 0.44. And finally, 75 of 75. According to police data, approximately 42% of cars driving on a particular section of highway are driving over the speed limit. If 6 cars are randomly selected during rush hour, what is the probability that at least one of them is driving over the speed limit? Okay, so this is an at least one problem. So I want to find what's the probability at least one success. And the police would definitely, in terms of just what it means, here's success is speeding, or is driving over the speed limit. Okay, but what we're going to do instead, and the probability of success while we're here, is 0.42. We are not going to find this, as we've talked about several times by now. It's easier and more direct to find 1 minus the probability of no successes. If we had no successes, that means we failed all 6 times. And to find that, the probability of no successes, then we can take the probability of failure to the 6th power. Because we had all failures, and we're going to take 1 minus that, and we'll be left with what we want. Well, the probability of failure we don't have, but we can find it. It's based directly on this. If the probability of success is 0.42, then the probability of failure is 1 minus 0.42, which is 0.58. So now we're back to this. We want 1 minus the probability of failure to the 6th, and we're home free. 0.9619, which is choice D. And we are done, and I am spent. So hopefully that has helped. Good luck as you study for your finals, and those of you working on your 75 questions to ensure yourself 20 correct answers. Good luck.